Hello and welcome to this video on object-oriented programming, and we're going into code in this video. However, there's some theory that might be interesting. I will probably make a video with theory on this as well, with slides, but maybe don't have time to publish it directly, so stay tuned for that. In object-oriented programming, it's another way of thinking. In here, you will learn how to create classes, and inside of classes, we have something called an attributes, etc. So there's a lot of different abstraction to what you're used to. And why are we using object-oriented programming? It's for creating more structured code so that we can reuse the code in a neater way, in a smarter way. So you basically put things that are similar that together into one class, and inside of the classes they have several methods which are similar to functions, but they are bound to the class. So this is what we're going through. And what I think is that we'll just start with the practice here. So we'll go into Visual Studio Code. So here I am in Visual Studio Code. As you can see, this is empty, and this is a folder, but you should definitely work with Git and GitHub and version control your code. So let's start with UVVNV. And if you already have a virtual environment using UV, you don't do this because this will overwrite your old ones. Okay, so we'll source.then bin activate to activate my virtual environment, and then UV pip install ipykernel. This is the only thing I need. Okay, and then patch, let's see, what do I need? OP. Actually, this one I will divide into several. So I will start with A, OOP fundamentals, not ipinb. We can do like this. Okay. And then change this one to my virtual environment. So a class is a blueprint which you use to instantiate several objects from this class. And the class itself is an object that's special in Python. But think of this, if you want to draw a house, then you have a blueprint on how to draw the house, right? And using the same blueprint, you can draw several houses. And each house is an object or an instance from this blueprint, right? So from the class, you can create several instances. However, the instances are not the same. So if you build two houses, they are not the same, and they just look the same, right? Because you're following the same blueprint. So this is how you can see the analogy of a class and object, or class and instance. And the terminology is that when you're creating an instance from a class, you're instantiating. So you're instantiating from this class. Okay, so let's start with an example. We can have class admission. And this admission, we should have, let me close down my Copilot. It's disturbing me. So here, def dunder init. So when you are creating your class, or when you're instantiating from your class, the first thing that runs is the dunder init method. So here you're initializing different things. So it runs when the class is created, or an instance of this class is created. Okay, so what can we have here? We can have self, we could have school, we could have program, we could have name, we could have accept, for example. So these are parameters to this method. This is a dunder method. It's a special method. So self dot school equals to school. And then I do self dot program equals to program. I do self dot name equals to name. I do self.accept equals to accept. And why do I do this? When I do this, so self refers to the instance itself. So it means that the instance will get the value of school from whatever you put in as a parameter. So for example, to this person, 1 equals admission to cool school. And let's say it's an AI program. And the name is, let's see, the name, we can do accept equals true, just to show that we can use keyword arguments also. And then you can choose the order you want, as long as you put in the other one as well. So if I type out person1, you can see what happens. So this is a Dunder wrapper. So it's another special method that is run by default when you just type it out like this in Jupyter Notebook. So what it does is that it says this person is in Dunder main dot admission at a memory address. So this is an admission instance at this memory address, but this doesn't tell us so much. So what we do is we can do person1 dot school, and you can see we get cool school. We can do person1 dot name, and you can see Gokcean. So these are attributes, and you access those attributes by doing dot. And what you can do is that you can change the attribute on the fly. So we can do person1 dot name equals Bella. So now person1 dot name is equal to Bella. You instantiated it with Gokcean, but you can change it afterwards. Okay, we can create another person. Person2 equals admission of Cooler School, data engineering, accept equals false, and we can have name equals Goreboard. Okay, so person2 dot program, for example, and person1 dot program. As you can see, they are different, AI and data engineering. And also person1 equals person2, what will happen? It's false. They are not the same. So what you can do is you can check out here the memory addresses. So you can do hex of ID of person1, and you can see this is the memory address that it lives in. And you can check hex of ID of person2, and you can see it's different memory addresses. So they live in different memory addresses, though they are not the same. Okay, let's move on to Dunder wrapper that I talked about. Dunder wrapper. So Dunder wrapper is used for representing the object or representing the instance. So you should write it in a way so that other developers can see how to create the object if possible. If there's too long and it's hard to write it out, then you can just describe what it does. So it's meant for other developers, while there's another Dunder class that's called Dunder string. You use it for printing out, so it's a little bit more different. You make it more suitable for end user. Okay, so let's copy this admission here. So remember, we have a class, it's a blueprint, and from this class we can instantiate several person, right? Or several instances, and those instances are not the same, right? So like we build a house, we build another house based on the same blueprint. They are not the same houses. Okay, so this is the main theory, and then we have Dunder wrapper like this. So Dunder is 2_, and it's a special method. So this has special ability or that special thing that happens when you type it out. For example, we can do like this, admission school. So you need to write out how people should use this class, right? How to instantiate from this class. So I will type out school, self.school, comma, program equals self.program, comma, name equals self.name and let's see, accept equals self.accept. This is string while this is a boolean, so this is correct, I think. And okay, to make it clearer, we can do like this. Okay, so now let's try this out. So we can have, for example, a student here is admission of school. And then we can call you, let's see what we can say, Java, and we can say, let's see, the name, right? And the name could be Victor Freeze. Okay, and let's see what else. Accept, let's say true. And then if we take a look at this student here, you can see, we get this done the wrapper. So this is much better than what we had before. Before, what did we have? We had this default on the wrapper that it has, that this lives in a certain memory address. However, now we get something more readable. You can see this is an admission instance of this school, this program, this name, and this accept. Okay. And also, if you print student, what will happen? You see the same. Why is that? Because Python will look for done the string when you're printing. But if done the string doesn't exist, then it will look for done the wrapper as a fallback. For example, I could define done the string self, and I can say print an admission instance, an admission instance, for example. And when I print this out, actually it shouldn't print, it should return. Okay? Or it should be even better written. For example, let's see, name, I could do this. Name is self.name is admitted to self.name, let's see, self.program applied to self.program, for example, and you can write out he has been accepted, true or not accepted, self.accepted. And one thing I forgot to say is that when you want to access the attributes within the class itself, you need to use the self. So all the methods will have the self as the first argument, and then by using the self, you can access all the attributes and all the methods that exist within the class. Okay. So now when I print the student, you can see Victor Freeze has applied to Java, accepted true. Okay, so you see that it looks for this done the string method. If it doesn't exist, it goes for the done the wrapper method. And similarly, if you do string of student, you will see that you get this string back. Okay, so this was a little bit about done the wrapper and done the string. Let's move on to some documentation. Or actually, we have... No, actually, I will leave the documentation in another video. So in this video, we went through very basics of OP fundamentals. So we created a class, and from that class, we have instantiated several instances. And then we have tested out getting different attributes. We have tested out checked the memory addresses that they live in two different instances. They are actually different. They live in different memory addresses, so they are not the same. And we also have done the wrapper and done the string and the difference between them. So I hope that you have learned a lot in this video. Remember to commit and push your code, and see you in the next video where we'll go further on into encapsulation. So that will be really interesting. See you there. Bye.